Well, welcome back everyone to another episode of the Apple II time capsule / restoration video I'm doing for some friends so they can see how we're doing here. I did manage to get the Apple working, and I have so far installed 3 cards. Basically the Reina Systems drive controller for the floppy disk drive, and this is the 80 column card to get 80 columns on the screen, and then also the RAM card, which is a language card / RAM disk made by, it was called the Apple Cache, made by Sorrento Valley Associates. It's pretty rare. I don't think any, I don't know how many were sold, but I can't find any other info other than what I have on the internet, so I posted a lot of it to share in case anyone else has one of these boards. The other card that's not in there right now I wanted to show you is the serial card. So this is the original Apple II serial card, and it was interesting because when it came it only had 300 baud, 2 speeds, 300 baud. Let me set it here so you can see it better. 300 baud and 1200 baud. Those are, no, was it 300 and 110? I think it was 300 and 110, something like that, or 300 and 1200 baud. Of course, back in the 70s, 300 baud was pretty much what you could push on the phone line, so you could put a modem on it, or you could switch it to 1200 baud and run a fast printer, or when the 1200 baud modems came out, you could run one of them. However, there is some information in the manual on how to change the clock frequency to this chip, which is the UART, so you can get higher speeds by modifying the divider circuit here. And that's what I did. If you look here real close, I've got a wire here. I pulled those 2 pins out of that IC, and that wire goes around to the back of the board, and it hooks to right here. So it comes around the back of the board and hooks to there. And then these 2 pins go off, and I did this so long ago I don't remember, but those 2 jumpers go from this chip here, which I pulled out, by the way. It's missing. Look, I sucked that chip out, so it looks like I took out one of the divider circuits, and that way you get a faster clock. And so with this board, the way it's set up, it can do 1200 and 4800 baud, which is a little bit better than 300 baud. In any case, back then it was pretty fast. If you go 4800 baud, 9600 baud, you were blazing back then. And anyway, so what I did also, and I'll show you why. Pin 1 normally on the serial connector, pin 1 normally on a RS-232 connector, pin 1 is frame ground, they call it. And it's the brown wire there, frame ground. But on this board, frame ground, basically, let me show you, this is crazy. So frame ground, you can see the brown wire there, went to that jumper and it went nowhere. It went, you can see the R9 right above it, there's this this solder pad, and it was just an empty pad, it didn't connect to anything. So I took advantage of that, and I ran a jumper. If you look on the back here, I ran a jumper right here from that pad all the way to 5 volts on the card. So from this pad to 5 volts. So now pin 1 on this DB25 is 5 volts. And there's a reason I did that, and I'll explain that to you here in a minute. So let's set this aside. So what I wanted to do was hook the Apple up and put the serial card in, and basically, you know, I didn't want to dial out with a modem. Obviously, there's hardly any modem services out there anymore today. So what I did is I wanted to go out over Wi-Fi to the internet and connect to some of these BBSs that are out there today on the internet. So interestingly enough, I discovered that there's a thing called a Zimodem. And what it is software that this gentleman wrote. I think it was a man, maybe it was a lady, I don't remember, but I think it was a guy. He wrote software for this module, for this chip made in China. It came out a while ago. This is an ESP8266. They also have a newer one, ESP32, I believe, but this is the first one, ESP8266, and it's a pretty powerful little microprocessor. It comes with Wi-Fi. You can see the antenna there with all the squiggly lines. That's the Wi-Fi antenna, 2.4 gigahertz antenna. And it's got serial ports capability in the processor, serial data in and out. And what this was designed for was to put microcontrollers that didn't have any internet access to allow them to be able to get internet access and send data to the cloud or to basically an IoT collection agent that would grab the data and archive it, basically for Internet of Things market. But anyway, this guy wrote software for this called Zimodem, and what it does is it takes and listens to the serial port and basically acts like an old Hayes modem. It was called an AT command set, and it emulates the Hayes modem. So anything that's hooked to this thinks it's hooked to an old-time Hayes modem. And it listens and it behaves just like it. If you give it a dial out command, it goes and dials out. But instead of dialing out over a telephone line, it tries to initiate a connection over the internet. So on the dial out command, instead of giving it a phone number, you give it an IP address and a port, and this thing will connect to that IP address and port as if it was dialing out and instruct the computer, hey, I've got a connection, and off we go. And the whole cool thing about this is, because it emulates the Hayes modem command set, any old software written for one of these retro computers that used to work with a Hayes modem still works today, because it has no idea it's not talking to a Hayes modem. So basically, I threw together a little circuit here, little prototype board, and what I did is it was cool because it fit perfectly between the pins of a DB25. So I basically took the serial data from the Apple that would be coming into DB25, and I run it to this IC right here, the LT1181. This chip converts the 12 and minus 12 volt signals from the Apple into TTL data, okay? 5 volt TTL. And then I also took the 5 volts that came in on pin 1 and ground and ran it to the chip for power. Also, I ran it to this module here through an adapter. There's an adapter. So this module, it comes with these wires that go to this. That's basically, and I'll fix this later, that's a 5 volt to 3.3 volt regulator, because this module on this processor runs on 3.3 volts. So you don't want to put 5 volts on it. So basically, this little adaptive board that I had, it basically takes the serial in and out and the 5 volts in, converts it to 3.3 so that this chip can run. And so what I did is I wired the receive and transmit out of this chip into this one. So TTL to this, into this, and into the Apple. So basically 12 volts from the Apple to plus minus 12 volts from the Apple into here, 5 volts to ground. So you get 0 or 5 volts for the logic there for your serial, and then into this chip. Now, this chip's 3.3 volts, but luckily the inputs are 5 volt tolerant. So I can take the 5 volt signal from here, feed it into here, and it has no problem with it. Then also the 3.3 volt out that it transmits out, this has no problem receiving the 3.3 volts as a logic 1 and ground as a logic 0. So that worked as well too. So it all went together perfectly. And basically what I do is I plug this into the serial adapter of the serial card, and then basically run some modem software, and off we go. I can connect to bulletin boards out on the internet. So let me plug all this stuff back in the Apple, and I'll give you an example of how that works. I'll be right back. Thanks for waiting. Everybody, we've got the serial card placed into slot 2. And that's usually where they go. Slot 1 was usually a printer card, like a parallel printer card. Slot 2 serial, we got the 80 column card in slot 3, and we've got the ESP8266 with the Zimodem software flashed on it, plugged into the parallel or the serial port here, DB25, and you can see it's lit up. It's getting power from the DB25. It's all working. So let me give you an example now of how this all works. Here, we'll kill the light. There we go. And let me get you in front of the monitor so you guys can kind of follow along. Sorry about that. Let's get this, see if we can clamp this thing here and see if it'll stay and not go anywhere. It's kind of hard to get, I'm using my phone, so it's hard to, there we go. There we go. So now you can kind of see the screen, and it's not too bad. You can see my reflection in it. I'll tell you what, I'll even kill the lights to the shop so that we'll kill the lights to the shop so you get a good clean video there. There we go. All right, so now you can see I've got the Apple running. It's in 40 column mode, and what we'll do, sorry about the waviness, I don't know why this thing's moving like that. I don't know if it's video on the phone. So what I'll do here, interestingly enough, let me give you an example also of the 80 column card. So there's a video connector that comes out of the Apple for the 40 column, and what you need to do, because I don't have the board that auto switches, you need to pull that connector out, plug it into the 80 column card, and type PR number slot, which in this case is 3, and there you go. So now we got the 80 column card running, okay? And let me boot up the software. So what I'll do here, I'll put my disk in with, I'm running software called ASCII Express. So let me go ahead and do IN number 6 for the slot that the floppy drive's in. You'll hear it boot up. And it should automatically load ASCII Express. There it goes. And as it loads ASCII Express, I configured ASCII Express to use the 80 column card. And so as soon as it loads, you'll see the screen clear and ASCII Express will come up. Now, ASCII Express was a communication program written in the 80s for the Apple to basically use, so if you have a serial card, you can talk to a modem. There we go, ASCII Express the Professional. You could use your modem to communicate with other computers and services and so forth. So let's go ahead and see if we can do an ATI. Also notice that when you're in 80 columns, 80 column card supports lowercase. So I've got lowercase characters on it. So there's ATI command, that's the AT command set, and you can see it's a Zimodem version 3.4, and it's Coco Wi-Fi version. So this was the guy that I got the firmware from. He compiled this for the Coco, the Tandy color computer. So it's no big deal. They're all pretty much the same AT command set. So it works fine. And it's connected to High Noon. There's the IP address. Don't hack me, you guys. Anyway, that's my internal LAN here in the shop. And it says ready, okay. So at this point, what I can do is let me go ahead and go uppercase. I can do an ATD. That would be for dial. And instead of putting the phone number in quotes, I can put the server's address. So I will put in there, let's see, which one do we want to hook to? The brewery. The brewery.serve beer. Wait, before we do this, hang on. I'm not going to do that yet. Hang on. I know you're waiting, but I want to show you something cool. So I want to give you the real experience that we used to have. So this is at 4800 baud. So what I'm going to do is I'm going to instruct the modem to go 1200, because that was the speed we usually had back then. So ATB 1200. I'll do a control Q so I get the prompt back from ASCII Express. I'll tell it I want to change the baud rate. I'll say low speed. And the card, like I showed you earlier, is strapped so that when you're in low speed, you're at 1200 baud. So I'll pick 1. So there we go. If I do I, now you can see the speed's a lot slower. That's 1200 baud. So AT dial the brewery.servebeer.com. And I think you put a colon, and the port was 3400. I think was it 3400? No, 6400. 6400. Usually they're 6502 for the 6502 bulletin boards. All right, 6400. Let's try that. Hopefully my memory doesn't fail me. Here we go. Connected. There we go. So there we go. There's the brewery bulletin board. There's a mug of beer. And it's asking me to log in. Now I've managed to log into the brewery BBS. And I think I can read my bulletins with the B command. And there's the experience of 1200 baud that we used to have before the internet, to go into, dial into a system and basically get messages and so forth. Anyway, I just wanted to share that with you. It works. I've tested with multiple connections on the internet. Also, the cool thing is you can also set up the Zimodem to auto answer, so it can listen for a telnet connection. If a computer connects to it over the internet, it will basically, it's like it answers the phone and sends the software, hey, I've answered the phone, ring ring ring, I answered the phone. And so you can actually dial into the Zimodem and take control of your Apple or other retro computer that way too, which is kind of interesting. I haven't experimented with that yet, but anyway, just a blast from the past I wanted to share with you guys. And if anyone's interested in the Zimodem firmware I use, I will link it in the comments below. All right, guys, have a good one. We'll talk to you soon.